All right, let's go through this poll question together. We have a particle is constrained to move in a circle with a 10-meter radius. So the radius of the circle this object is traveling in is 10 meters. At an instant, the particle's speed is 10 meters per second. So we know at some instant, v is 10 meters per second, and it's increasing at a rate of 10 meters per second squared. So the speed itself is increasing at 10 meters per second squared. So we can basically say that dv dt is 10 meters per second squared. And then we're being asked to calculate the angle between the particle's velocity and the acceleration vector. Now this is non-uniform circular motion because the velocity is not staying constant at a 10 meters per second. But there is both since we are traveling in a circle, there's going to be both a radial acceleration or a centripetal acceleration due to this object traveling in a circle. And then there's also going to be a parallel or a tangential direction due to the object speeding up. So the acceleration that's perpendicular to the direction of motion, meaning the radial acceleration or the centripetal acceleration, is going to be v squared over r. So the instant at which we're considering this is when the velocity is 10 meters per second squared divided by the radius of the circle that this object is traveling in is 10 meters. So we simplify that and get that the radial acceleration is 10 meters per second squared. And then the tangential acceleration, or the acceleration parallel to the direction of motion, is just dv dt, which we were given to be 10 meters per second squared. So if, let's say, the object happens to be traveling in this direction, so let's say v at some instant is in this direction, well then we just found that a perpendicular has a magnitude of 10 meters per second squared, and a parallel also has a magnitude of 10 meters per second squared. Let's put units on both of these. Meters per second squared. So if we have a vector that's the sum of a parallel and a perpendicular, we need to figure out what angle this is. So let's redraw a perp here equals 10 meters per second squared, and we want to know what this angle theta is. Well, we know this is 90 degrees, and we have an isosceles triangle here basically because both of these sides are equal, so we know theta is going to be 45 degrees. Theta is 45 degrees, and that's this